Hello everyone, welcome back to your favorite channel Vedantu Malayalam. This is Goutham, your mathematics master teacher, and welcome back to another exciting session. So in today's session, we are going to discuss about trigonometry, the whole trigonometry in one go. And let me tell you, this is a very important chapter for your KEAM examination. In KEAM 2023, you can expect around at least 5 to 7 questions from this particular chapter. So that is one of the reasons why you have to definitely prepare this chapter in a very good way. And also guys, in addition to that, trigonometry is such a chapter which is going to be used. The concepts of trigonometry are going to be used in other chapters as well. You take calculus, you take algebra, you take geometry. In all those chapters, the concepts of trigonometry, the formulas of trigonometry are definitely going to be used. Okay, so that is the reason this chapter is going to be very important for you. So in this chapter, I'll be discussing everything that is required for you to crack your KEAM examination. So with that, let's begin the session, guys. Okay, so the first thing in this particular session is what are we going to discuss? Well, you can see here clearly, we are going to discuss the basic stuff, the basics of trigonometry. We'll be discussing about the domain, range and graph of trigonometric functions. We're going to discuss about the period of trigonometric function. We'll be discussing about the compound angles, the extreme values of trigonometric function, and finally the multiple and submultiple angles. Okay, I'm going to teach you all the formulas that you have to remember in this particular chapter. Definitely there will be a lot of formulas in this chapter, but let me tell you guys, you have to remember them. Okay, then only you can apply them in different chapters and also in different questions. The formula application is very important. You need to know the formula. Okay, so what you can do is, I'll be sharing this PDF after the session anyway with you guys. You can basically make a note of all these formulas and you can keep memorizing them, so that in your final examination definitely you can remember all that formulas. Okay, chalo guys, with that let's begin the session today. So the first thing is that let's start with the basic formulas. Okay, you can clearly see that if you see in trigonometry, in class 10th also we have studied this basic identities, right? We know that sine square theta plus cos square theta is 1 plus tan square theta is secant square theta, and 1 plus cot square theta is cosecant square theta, the basic identities. Okay, and after that, well, we have something called as ASTC rule. Now what do you mean by this ASTC rule? What do you mean by this ASTC rule? Well, pretty simple. ASTC rule just tells you which trigonometric ratio is going to be positive in the given quadrant. Okay, for example, you just see this one, guys. Let us say this is going to be your first quadrant. This one right here is going to be your second quadrant. Okay, this is going to be your third quadrant, and this is going to be your fourth quadrant. Okay, now try to understand. In the first quadrant, you can take A, second quadrant take S, third quadrant we have to go with T, and fourth quadrant let us take C. So ASTC rule. Now according to ASTC rule, what is this indicating is, in the first quadrant we have taken A. So this simply implies that in the first quadrant all the trigonometric ratios are positive. Let us say if your angle is going to be in the first quadrant, then definitely all the trigonometric ratios at that particular angle is going to give you a positive value. But let us say that your angle is going to be in the second quadrant. In that case, only sine and cosecant are going to be possible. Remember this. Only sine is going to be possible, and the reciprocal of sine, which is cosecant, that is also going to be positive. In the third quadrant, which is going to be T, so what does that mean? Only tan is going to be positive, or the reciprocal of tan, we can say that is cot, is going to be positive. And in the fourth quadrant, C, and what is C indicating here? The cosine, or I can say cos, or the reciprocal of cos, which is secant, only these two are going to be positive. So depending upon where your angle is going to lie in. Is it going to lie in the first quadrant? Is it going to lie in the second quadrant? Is it in the third quadrant or fourth quadrant? You can easily decide which trigonometric ratio will be positive, which trigonometric ratio will be negative. For example, tan in the second quadrant is negative because in the second quadrant only sine and cosecant is positive. Similarly, in the fourth quadrant only cos is going to be positive and its reciprocal is positive. The other trigonometric ratios like sine, cosecant, tan and cot, they are going to be negative. So I hope this is clear for you. So this is something called as ASTC rule. Okay, you can remember this rule through something like all silver teacups or all students take coffee. So whichever is easy for you to remember, just go ahead with it. Okay, so now let me go to the next slide. Now here you can see, let me start discussing about the sine of minus theta, cos of minus theta and tan of minus theta. What would be the results of this? And also guys, remember, we'll not be discussing the proof of any of these results because for your KEAM examination, the proof is not required. You know, you have to just remember the result and you have to know how to apply this result. That's it. Okay, so sine of minus theta, you know, it's going to be minus sine theta. Cos of minus theta is cos theta. Tan of minus theta is minus tan theta. And then maybe you might be wondering, then what about the cosecant theta? What about the secant theta? What about the cot theta? Well, for that, a pretty simple logic. If sine of minus theta is minus sine theta, don't you think the reciprocal of sine is also going to follow the same logic? So we can say that cosecant of minus theta is also going to become minus cosecant theta. Similarly, I can write down secant of minus theta. Well, if cos of minus theta is cos theta, its reciprocal is going to follow the same logic, right? So secant of minus theta, it's going to be secant theta. And finally, cot of minus theta, that is going to be minus cot theta. So this is what you're going to get, guys. Okay, now maybe you might be looking at this table and wondering, okay, what is this table about? Okay, what all these things are indicating? Now let me tell you, depending upon where your angle is going to lie in, which quadrant the angle is going to lie in, what happens is that we can actually simplify the given angle. Okay, I'll try to explain this through a very simple example. Let us say till now we know the value of sine 30, yes or no? We do know what is sine 30 going to be. Well, what is sine 30? It is 1 by 2. We know the value of sine 45. Sine 45 is 1 by root 2. We know something called sine 60, which is root 3 by 2. We also know sine 90 degrees, which is 1 by 2. And these are standard angles, 30, 45, 60, 90, sine 0. Sine 0 is basically 0. So these are basically standard angles. So we do remember these values. Okay. Sorry, sine 90 is not 1 by 2. I'm very sorry. Sine 90 is basically 1. Sine 90 is 1. So these are the standard values of the standard angles. Okay. Now what if I give you something like this? Let's say you need to get me what is the value of sine 210 degrees. Okay, or let's say what if I give you the value of sine 120 degrees. Now this is something which we have not discussed yet enough, right? Yes or no? We have not discussed this concept till now. We know only if those angles are given, we know how to find the value. But what if, you know, we have something like 210 or let's say 120 degrees, something which is greater than 90. In that particular case, how do we solve these questions? How do we get the results of this? Now this is very, very important, guys. Okay, now what we will be doing here is pretty simple. We will be following a very simple logic. Okay, there are basically two simple logics you have to remember. What is the first logic? Remember that, let's say, if the angle is going to be in this particular format, let's say it is going to be in the format n pi plus or minus theta. N pi plus or minus theta, where n you can basically take it as any integer. Then remember, and here theta is the acute angle. What is theta going to be basically here? The theta is going to indicate the acute angle. So if n is an integer and theta is the acute angle, and if you have your angle, that is this angles in this way, n pi plus or minus theta, then guys we can always write something like this: sine of n pi plus or minus theta is going to become sine theta. That is, the trigonometric ratio is not going to change. Now whether this is positive sine theta or negative sine theta, well, that is another discussion. We'll do it, just after 5-10 minutes. But right now all you have to remember here is, whenever you have the angle in this way, n pi plus or minus theta, the trigonometric ratio does not change. I can give you an example like this. So remember simply that if you have the angle in this way, then remember that the trigonometric ratio does not change. So we can write down the trigonometric ratio or trigonometric function does not change. Okay, it's going to remain the same, guys. Like let's say n pi plus or minus theta is there, you can directly take sine n pi plus or minus theta as plus or minus sine theta, where theta is the acute angle. The same logic can be applicable for cos, tan, cot, cosecant as well as secant. Okay, I hope this is clear for you. So if using that logic, now yes, I try to observe this, using that logic, sine 210, can I write it as sine of 180 degrees plus 30 degrees? Definitely. And what is this 180? 180 is nothing but pi, right? You have to know this, dude. What is this, guys? 180 degrees is nothing but pi radians. We already know this. So this is like this format, n pi plus or minus theta format it is, where theta is acute and this is like pi. So what I told you, this can be directly written as sine 30. And whether it's going to be plus or minus, I'll tell you. How do you decide whether this will be plus sine 30 or minus sine 30? But I hope this is clear for you. Similarly, sine 120 is there. Okay. Now this can also be written as 180 minus 60, 180 degrees minus 60 degrees. And again you can clearly see it is in this format. So there is no need to change your sign, the trigonometric ratio. So this will remain the same and you are going to get sine 60 degrees. Okay. Now what if your angle is going to be in this way rather than this way? What if your angle is in this particular way? So let me write down the angle for you. So what if the angle is like this: 2n plus or minus 1 into pi by 2 plus or minus theta. What if your angle is something like this, which is odd multiple of pi by 2 plus or minus theta? Okay, then remember guys, remember again, n is going to be an integer, theta is going to be an acute angle. Then remember here the trigonometric ratio is going to change. The trigonometric ratio will change. The trigonometric ratio, what is going to happen, will definitely change. How does it change? From what to what? That is important. So let me write it down for you. So here, observe this one, guys. The trigonometric ratio is going to change something like this. If it is sine, the sine is going to change to cos, or if it is cos, cos will change to sine. Let us say you have tan, tan is going to change to cot, or cot is going to change to tan. Similarly, you have secant. Secant is going to change to cosecant, or let us say cosecant is going to change to secant. So this is what you are going to remember. Okay, this is how you have to change the trigonometric ratio. I can give you an example for this. For example, let's say you have something like this. Okay, you have sine of okay, sine of 2n plus 1 into pi by 2, 2n plus 1 into pi by 2. So let me write it down that for you. So it's sine of 2n plus 1 into pi by 2 plus theta. Let's say you have 2n plus 1 into pi by 2 plus theta. Okay, now since you have the angle in this particular way, what is going to happen? The trigonometric ratio is going to change. So sine is going to become what? It is going to become cos. Now Whether it's going to be positive or negative cos theta, that we need to decide. But I hope this entire discussion is clear for you. Okay, so remember that if your angle is going to be in this way, the trigonometric ratio is not going to change no matter what. Okay, and if your angle is going to be in this particular way, the trigonometric ratio is going to change. How it is going to change? If it is sine, it goes to cos, or if it is cos, it's going to be sine. The same thing with tan and cot, secant and cosecant, and here is your example. Okay, so similarly, if you observe here guys, if you can observe here, this can also be written in this way. If you see sine 120 degrees, okay, or let us say sine 210 degrees, I can also write the same in this way, sine of 270 degrees minus 60. Can I write it in that way? Yes sir, definitely we can do that. So sine 210 can be written as 270 minus 60. Okay, and 270 is actually an odd multiple of pi by 2. 270 is 3 into 90. 90 is pi by 2, dude. You see here, 180 is pi. So pi by 2 is going to be 90 degrees. So I hope you're getting my point. So here this angle is basically in this terms. The angle is going to be in this way. So what is going to happen? Now we can change the trigonometric ratio. The sine is going to become cos. Now this is cos 60. Now whether is it positive cos 60 or negative cos 60, that we need to decide. Okay, but definitely the trigonometric ratio will change. The same happens with this also. You can write it in this way, or the same question you can also write it as sine 120 can also be written as sine 90 plus 30. Again, the angle is going to be in this particular format, so trigonometric ratio will change. So sine is going to become cos. So I'm going to get cos 30 here. Okay, so I hope this is clear for everyone. Now the question is all about whether are we getting a positive sine 30 here, or a negative cos 60, or a negative sine 30. What is going to be the sign of the resulting value? Okay, so how do you decide it? Well, for that we just have discussed about a rule called ASTC rule. So let me just draw a graph for you again here. So here let me draw a graph. Here is your first quadrant, second quadrant, third quadrant and the fourth quadrant. Okay, and again let me just write down the ASTC rule once again. A, S, T and C. Now what you have to do is, whatever the angle is given for you, you need to decide in which quadrant the angle is going to lie in. For example, let's say 210 degrees is given. Okay, now in which quadrant 210 degrees is going to lie in? It's pretty simple. Let's see that. So for example, how do you decide it? First thing guys, if you observe, this is your 0 degrees, this is your 90 degrees, this is your 180 degrees, this is your 270 degrees, and again you end up coming here. So basically you have covered a full circle. So this is 360 degrees. Okay, now tell me, 210 degrees lies between 180 and 270. So 210 degrees is going to be in the third quadrant. In the third quadrant, only tan and cot are positive. Then what about the sine? And again you have to observe the trigonometric ratio given in the question rather than going with the trigonometric ratio in the result. Don't go with this trigonometric ratio which you got in the result. Okay, you have to go with the trigonometric ratio which is present in the question. So you have a sine here, and 210 degrees is in the third quadrant. So sine in the third quadrant is negative. So what we will be doing is, we'll go with a negative sign here. Simple. Sine 30 value, how much is that? 1 by 2. So the answer for this is minus 1 by 2. How simple that is. Right. Similarly, what about 120? 120 guys, it lies between 90 and 180. So second quadrant. So in second quadrant, what is going to happen? Well, sine is positive in the second quadrant. So whatever result we got plus sine 60, that is going to be how much? It's going to be root 3 by 2. So this is the answer. Similarly, again, you can see here clearly sine of 270 minus 60 it was. So 270 minus 60. So basically the sine 210 degrees. So again, sine 210, as I told you, it's in the third quadrant. Sine is going to be negative. So here it's going to be minus cos 60. that is minus 1 by 2, and observe both the values are same. You do it in this way or you do it in this way. You write 210 as 180 plus 30 or 270 minus 60 and apply this logic and apply this ASTC rule, you end up getting the same value. So there should not be any confusion that should I go with this one or this one, should I write this angle as 180 plus theta or 180 to, or a multiple of pi by 2 plus theta, because whatever you write, finally you end up getting the same result. Okay, the same thing for this one also. This is also going to be anyways my plus cos 30, and cos 30 is root 3 by 2, so the same values. So this is the entire discussion, guys. Okay, definitely this is very important for you, because finding such values is a frequent question. You have to be, we will be using that throughout this chapter. So I hope this is clear for everyone out there. Okay, so this is about the entire concept of how do we figure out, how do we basically solve angles of this type or this type. Okay, so I hope this is clear for you. And to basically put that entire thing in a single table, this is how I've done it. Okay, for example, let's say you have n pi minus theta and you have alpha to be this one, sine of n pi minus theta. Then what you can do is you can easily decide according to the value of n. What you can do is, let's say n is equal to 2, put n is equal to 2 here, accordingly you'll get the value for this. Okay, so this table is there for you, but again I would say this table is just for your revision. Okay, but it's very hard for you to remember everything. So what you can do is, whatever the logic I told you just now, okay, remember that logic. If you know that, I think any question from the trigonometric ratio of an angle, okay, which is greater than 90, like let's say you have 210 degrees, or let's say you have 240 degrees, or let's say 360 degrees, something like that, you'll be comfortable solving it. Okay, so I hope this is clear for you. Now let me do a few questions based on the same. For example, let's say sine 210. I think we have just done this question. Okay, I hope it's clear. Now what about this question, sine tan of 480? Now tan of 480, I can write it in this way, right man? What is tan of 480 degrees? I can write it as 540 degrees minus 60 degrees. Why 540? Because observe, 540 is a multiple of 180. 540 is 3 times of 180 degrees. Agreed? So since the angle is n pi minus theta, the trigonometric ratio will not change. So I'm going to get directly tan 60 degrees. Whether it's positive or negative, it depends upon where this angle, which is 480 degrees, is going to lie in. Now let me tell you, here the students might get confused, because 480 degrees, plotting the 480 degrees might be a bit trouble for you. For example, let's say you start here, this is 0 degrees, here you have 90, here you have 180 degrees, here you have 270 degrees. Again, here you come up, again you complete the entire circle, you go with 360 degrees. You can continue further. You can add 360, 90 to 360, and you end up getting 450 degrees. Again, you add a 90 degrees to this. Okay, so what is going to happen? This is what is going to happen. 450, if you add a 90, so that is where you get 540 degrees. Okay, so 480 degrees is something between 450 and 540. So that is nothing but it's going to lie in the second quadrant. And in the second quadrant, we do know that tan is negative. So it's going to be minus tan 60. And the result is minus root 3. So I hope this is clear for you. Now this question is a homework question for you, a simple homework question. I want you to try out this question and let me know what is the right answer in the comment section below. Okay, so I hope this is clear. Now let me go to another question. Now you see this question, guys. Now it seems kind of a lengthy question, seems kind of difficult, but let me tell you, it's a pretty simple one. What is given? Sine square pi by 10. Okay, fine. Let me write down sine square pi by 10. Now sine square 4 pi by 10, well, can I write it in this way? Sine square of pi by 2 minus pi by 10. Take the LCM, you would end up getting the same thing. Okay. Similarly, what about this one, guys? Sine square of 6 pi by 10, you can write it as pi by 2 plus pi by 10. You can definitely write it in this way. And sine square of 9 pi by 10, what is going to happen? This can be written as pi minus pi by 10. Now what is the use, why are we writing in this particular way? What is the use of this? Pretty simple. If you observe, this is sine square pi by 10. Now this is sine of 90 minus theta. Now if the angle is in this way, what is going to happen? The trigonometric ratio is going to change. The sine is going to become cos. So it will be cos square pi by 10. Again, here also it's in the same format. So again the trigonometric ratio will change to cos. So cos square pi by 10. And here it is 180 minus theta. If it is in the format of n pi plus or minus theta, the trigonometric ratio is not going to change. Correct? So what I can do, this is going to be simply sine square pi by 10. Now observe here, sine square theta plus cos square theta, sine square theta plus cos square theta, and that is 1. So I'm getting 1 plus 1, and the result here is simply going to become 2. So I hope this question is clear for you guys. Okay, then you have this particular question. What is happening here? Cot pi by 16, cot 2 pi by 16, cot 3 pi by 16, so on, cot 7 pi by 16. Okay, again simple logic. Cot pi by 16 is given. Okay, now what is cot 2 pi by 16? Let me do one thing, guys. Let me club this cot pi by 16 with cot 7 pi by 16. You'll get to know the reason. Let me club these two terms, the first and the last term. Similarly, let me club cot 2 pi by 16 with cot 6 pi by 16. I hope it's clear for you. Okay. Similarly, you can club cot 3 pi by 16, cot 3 pi by 16 with cot 5 pi by 16. Okay. And finally, only one term will be left out, which is cot 4 pi by 16. Now what is going to happen is, you can clearly see cot pi by 16 into, this can be written as 7 pi by 16. I can definitely write this as pi by 2 minus of pi by 16. We can definitely write it in this way. Okay, and similarly the same thing happens with this cot 2 pi by 16 into cot 6 pi by 16 can be written as pi by 2 minus of 2 pi by 16. We can definitely write it in this way. Okay. Similarly, this thing also can be written in this way. Cot 3 pi by 16 into cot 5 pi by 16 can be written as pi by 2 minus of 3 pi by 16. 3 pi by 16. And finally, cot 4 pi by 16, this is 4 ones, 4 fours are cot 45, and that is simply 1. Okay, now observe this, guys, observe this. This is cot 90 minus theta, which is tan theta. Now tan pi by 16, so basically I can write it down here itself. This is tan pi by 16, and what is cot pi by 16 into tan pi by 16? That's 1. Similarly, the same thing is going to happen here as well. This both is going to cancel, because this is going to become tan 2 pi by 16, and tan 2 pi by 16 into cot 2 pi by 16 is again 1. Similarly, this term and this term is going to get cancelled. So I'm getting 1 into 1 into 1 into 1. So what is the final result of this? That is simply going to become 1. So I hope this question is clear for all the students out there. Okay, chalo. So that was about the basics of trigonometry. You have to definitely know that. Now in addition to that, you also asked, maybe in different other chapters, other calculus or algebra, or let's say geometry, it's very important for you to know the domain, range and graph of the trigonometric functions. Okay, so let's discuss the domain, let's discuss the range, and how does the graph of each and every trigonometric function look like. So let's say domain. The domain of sin x is all the real numbers. The range of sin x is minus 1 to 1. Okay, and how does the graph look like? Let me show that to you. So let's say this is going to be your x-axis and this is going to be your y-axis, and this is how the graph of sin x is going to look like. Okay, where the maximum value of sin x is 1, the minimum value is minus 1, here it's 0, here it's pi by 2, here it's pi, here it is 3 pi by 2, and here it is 2 pi, and this just continues. Okay, so this is how the graph of sin x is going to look like. Similarly, if you want to go with the cos x, so let's say you have y is equal to cos x. So if you want to find out what is going to be the domain, range and graph, the domain of cos x is also going to be all the real numbers like sine. The range of cos x is going to be basically between -1 to 1, and if you want to get the graph of cos x, it is going to be something like this. So let's say it's y-axis and this is going to be your x-axis. So the range, the graph of cos x is going to be something like this. So this is how the graph of cos x is going to look like, where see this is 0, okay, and this is going to be pi by 2, and this is going to be pi, and this is going to be 3 pi by 2, and the graph is going to continue. So this is how the graph is going to look like, okay. Then we have the tan x. Then what about the tan x graph, guys? So regarding the tan x, the domain is going to be all the real numbers except 2n plus 1 into pi by 2. So what does this mean is, at odd multiples of pi by 2, tan is not defined, right? We know that tan 90 is infinity. Similarly, tan 270 is infinity. Similarly, tan, if you take any odd multiple of pi by 2, it's going to be infinity. And we know that tan, infinity is not good for functions. At infinity, the functions are not defined. So that is the reason when we find the domain of tan x, it's all the real numbers excluding 2n plus 1 into pi by 2. And what about the range? The range is all the real numbers. And if you want to know the graph of tan x, this is how it is going to look like, okay. So you can see here, this is going to be your x-axis, this is your y-axis, and let me just draw the points here. So let's say this is 0, this is pi by 2, this is 3 pi by 2, and this is minus pi by 2. And let me do one thing, guys, let me just draw the lines like this, okay. And the graph of tan x is going to be something like this. So this, sorry, I think I have drawn it in a wrong way. So the graph of tan x is going to be something like this. The graph of tan x is going to be something like this. Yep. So this is how the graph of tan x is going to be like, okay. So similarly, you can also draw it in here. Similarly, in the same, in the same interval, the graph is going to be like this, something like this. So this is how the graph of tan x is going to look like, okay. So just look it in the book once again after the class. You'll get to know, you'll have a better idea. But this is what is happening. At pi by 2, it goes to infinity. At minus pi by 2, the tan goes to minus infinity. So this is how the graph is going to look like, okay. Next you have the cot x. For cot x, the domain is going to be, well, all the real numbers except the multiples of pi, okay. And what about the range? It's all the real numbers. And if you want to know the graph of cot x, this is how it is going to look like, okay. So this is how it's going to look like. And remember, guys, here this n is going to belong to the integers. The same here as well. The n is going to belong to the integers, okay. Now coming to the graph, this is 0. Let's say this is going to be pi. This is pi by 2. This is 3 pi by 2. This is 2 pi. And let's say here you have minus pi, okay, and here you have minus pi by 2. So the graph is like this. So for this, let me just draw it in this way, okay. So then you have like this, okay, and then you have like this, okay. So the graph is going to be like this, guys. The graph of cot x is going to be like this, something like this. The graph of cot x is going to be like this, okay. And you can clearly see cot pi by 2 is 0, but at 0 and pi, what is going to happen is cot is tending towards infinity. At 0, it's tending towards positive infinity. At pi, it's tending towards the negative infinity. So I hope this is clear for everyone, okay. And finally, you have the secant x and cosecant x. For domain, all the real numbers, you can take all the real numbers here except the odd multiples of pi by 2. For the range, it's all the real numbers except -1 to 1. And if you want to know the graph of secant x, this is how it is going to look like, okay. So you can clearly see, let's say it's going to be 0 here, and then you have pi by 2, and let's say you have a pi here, and this is minus pi by 2, and you have minus pi, So the graph is like this. The graph is going to be like this. And let's say this is your 3 pi by 2. So this is how the graph is going to look like. So the graph of secant x is basically, and yeah, minus pi by 2. So yep. So the graph of secant x is going to be like this, guys. This is how the graph of secant x is going to look like. Okay. This is how the graph of secant x is going to look like, where this value is 1 and here the value is minus 1. Okay, and accordingly it's going to continue. So you can clearly see what is happening is at pi by 2 and minus pi by 2, the secant will be tending towards positive infinity. And again to this side, again this is pi by 2 to 3 pi by 2, second and third quadrant. So at pi by 2 and 3 pi by 2, it will be tending towards the negative infinity, because in second and third the secant is negative. Okay, so I hope this is clear for everyone. And similarly you have cosecant. So cosecant is again, domain is all the real numbers except n pi, the range is all the real numbers except minus 1 to 1. And again, if you want to draw the graph of cosecant x, it looks similar to secant x but with a small change here. So here let me take 0, let me take pi by 2, and again you have pi, and you have 3 pi by 2, and you have 2 pi. So let me just draw these lines here, right, at the multiples of pi, and you can clearly see here that this is how the graph is going to look like. Okay, so this is 1, the maximum, this is the 1 value, and this is the minus 1 value. You can clearly see, because for cosecant x at 0 and pi, the cosecant x will be tending towards the positive infinity, but in the pi to 2 pi region, that is the third and fourth quadrant, where cosecant is negative, this will be tending towards the negative infinities. Okay, so I hope this is clear for everyone out there. So now let me do one thing, let me go to the next topic, which is going to be the period of trigonometric functions. Now what do you mean by period? If you observe the graph of trigonometric functions, guys, the graph is repeating after a certain interval of time. For example, if you see sin x graph, the graph keeps repeating, right? The graph keeps repeating. Again, this side also, the graph keeps repeating. So such graphs where after a certain interval, if the curve is going to get repeated, if the graph keeps repeating for that function, then that function is called as a periodic function. Okay, now what is the periodicity then? So what is going to be the period of that function? What does that mean is, if you observe from this interval to this interval, from 0 to 2 pi, if you observe the shape, if you observe the graph, after 0 to 2 pi also, you can see the same shape is repeating. If you see here, guys, if you see that between 0 to 2 pi, this is the shape, right? And if you observe after this interval, the graph is again repeating, the same graph is repeating. So the interval, the shortest interval after which, okay, the graph is keeping repeating itself, that shortest interval is nothing but the periodicity of that function. So accordingly, if you want to know the period of sin x, it is simply going to be 2 pi. That is the length of interval. This is nothing but the length of interval, the length of interval, the length of interval after which the shortest length, in fact, the shortest length of the interval after which the graph keeps repeating. The graph keeps repeating. So I hope this is clear for everyone out there. Okay, so this is 2 pi. Similarly for cos x, the shortest interval after which the graph keeps repeating is 2 pi. For tan x, it's going to be pi, because if you observe here, for tan x graph, you can clearly see here, guys, the tan x after an interval of minus pi by 2 to pi by 2, that is the interval length pi, the graph is repeating. So that is the reason the period of tan x is pi. Now also remember that if sin x period is 2 pi, then cosecant x is also going to have the same period. Since sin x, cosecant x is the reciprocal of sin x, it's going to have the same period. The same goes with cos x. So secant x is going to have the same period. If tan x period is pi, cot x period is also going to become pi. Okay, so I hope this is clear for everyone out there. Okay, but sometimes, instead of giving you like this, he might be giving you something like this. Example, 2 sin x, or let's say sin x whole divided by 4. Now what about this functions? Will the period change? Is this still going to be periodic? Yes, it is still going to be periodic. That is, remember, if f is periodic, then lambda into f, where lambda is a constant, is also going to be periodic, and also the period is still going to remain the same. So for both the functions, both these functions, the period is still going to become 2 pi. Remember that. Okay. But what if you have something like this? Sine of 4x plus 7. Okay. What is the periodicity of this particular function? How do you decide it? Well, for this you need to apply a very simple logic that, let's say if p is going to be the period of f of x, then for f of ax plus b, the period is p by mod n. So what does that mean is, let's say for sin x, we know that the period is going to be 2 pi. Then what about sine of 4x plus 7? What is going to be the period for this particular function? All you have to do is, you take this period of sin x, which is 2 pi, and divide it with the coefficient of x in this particular angle. So you see coefficient of x is 4. So divide this 2 pi by 4, you end up getting pi by 2, and that is going to be your answer. So whenever you have this type of functions, sine of ax plus b, or cos of ax plus b, or tan of ax plus b, use this logic. Okay. So I hope this is clear for everyone out there. Now what we will do is, now let us get into some formulas, the formulas which you have to definitely remember. Okay. So first, the compound angle formulas, guys: sine of a plus b, sine of a minus b, cos of a plus b, cos of a minus b, tan of a plus b, and tan of a minus b. Now here there is nothing to do, you just have to remember this. Okay, there is no need of proof of all these formulas anyway. He's not going to ask any question from that. You need to definitely remember all these formulas, guys. In addition to this, cot of a plus b as well as cot of a minus b. So what you can do is, you can pause the video, write down all the formulas in one page, and keep memorizing it, or else you can take a screenshot and afterwards you can write it down. So I hope this is clear for you. Now what will we do is, based on this compound angle formulas, there are certain important results which you have to definitely remember. For example, the first result, sin a plus b into sin a minus b. The result of this is this: sin square a minus sin square b, or cos square b minus cos square a. Similarly, cos a plus b into cos a minus b, this is going to be the result: cos square a minus sin square b, or cos square b minus sin square a. So I hope this is clear for you. Next, now using these results, using this particular results, using this compound angle formulas, you can easily figure out all these values. Let's say you want to find out sin 75. Sin 75 is not a standard angle. 75 is not a standard angle. But still, you can find sin 75 something like this. Sin 75 can be written as sine of 45 plus 30. Agreed? And what is sine of a plus b? Sin a cos b, sin 45, 1 by root 2, cos b, root 3 by 2, plus cos a sin b. So it's going to be how much? Cos 30. Sin a cos b plus cos a sin b. So 1 by root 2 into 1 by 2. So what you're going to get in this case, root 3 plus 1 divided by 2 root 2, and the same thing is there. Okay. And also, guys, sin 75 can be written as cos 15, right? Sin 75 can also be written as sin 90 minus 15. And what is sin 90 minus theta? It's cos theta, so cos 15. So in this way, this is what we got. Okay. Similarly, you can easily understand how we got the next one, this cos 75 value, the tan 75 and cot 75. So do remember these values, guys. They are going to be important for you. Okay. So now what we will do is, let's apply this, whatever we have discussed till now. For example, let's say you want to find out sin square 52.5 degrees minus sin square 22.5 degrees. Now what will you be doing? You don't know the value of 52 degrees, right? 52.5 degrees, sin square 52.5. You don't know the value of sin square 22.5, right? Now here what we can do is, but we do know this simple logic that sin square a minus sin square b, sin a plus b into sin a minus b. So this can be written as sin a plus b, that is 75, into sine A minus B, and that is 30. Now sine 75 value, we know this here directly, which is root 3 plus 1 divided by 2 root 2, and sine 30 is 1 by 2, and this is going to be your answer. So I hope this is clear for all the students out there. Okay. So similarly guys, after this we have extreme values of trigonometric function. That is, let's say you have a trigonometric function like this, a cos x plus b sin x plus c, okay, something like this. If you want to find the, let's say, extreme values of this expression, that is, what is the maximum value, what is the minimum value, this is the formula. For maximum value, use this formula. For minimum value, you can use this particular formula. For example, let's say you have 3 sin x minus 4 cos x, and I want to find out what is the maximum value of this. What is going to be the maximum value of this? How are we going to do here? Very simple. All you have to do is compare it with this one. C is 0, okay, and A is 3 and B is minus 4. So 3 square plus minus 4 whole square, and this is simply going to become 5. Similarly, if you want to find the minimum value, that is simply going to be minus 5. I hope it's clear for you. Okay. Similarly, you have another question. Now here also you can apply the same logic. Always the angle need not to be x, guys. But remember, sine and cos should be having the same type of angle. You can see x plus pi by 3, x plus pi by 3 is there. So here also you can apply the same logic. So if you want to find the maximum value here, so the formula is going to be c minus 3 plus under root of a square plus b square. So a, the coefficient of x, which is going to be 2 root 2, or you can say coefficient of cos. So 1 square plus 2 root 2 whole square, and this is going to be 8 plus 1 9. So minus 3 plus 3, that's going to be 0, the maximum value of this expression. And if you want to find out what is the minimum value, you'll get minus 3, and that is minus 6. So I hope this is clear for all the students out there. Okay. So now let me go to the next one, which is multiple and submultiple angle formulas. So here, sine 2a formula. Now guys, remember, you need to know all the formulas. Let's say sine 2a is 2 sin a cos a, but sine 2a is also 2 tan a by 1 plus tan square a. So remember, you need to write sine 2a in terms of tan. You need to remember the formula, sine 2a formula in terms of tan, also this particular formula. Similarly, cos 2a, you need to remember the formula in terms of cos, in terms of sine, in terms of tan. All these formulas are important. And tan 2a is 2 tan a by 1 minus tan square a. Okay. Then you have sine 3a formula, the cos 3a formula, the tan 3a formula. Sine a, you can write it in this way, or you can also write 2 sine a by 2 cos a by 2, the submultiple angle. So guys, the logic behind here is, remember, if the angle is 2a here, you're taking the angle as a and a on the right hand side. That is, whatever the angle you're taking on the right hand side, the left hand side should have double of that angle. Okay, the same logic is applied here. I can write sine a as 2 sine a by 2 cos a by 2, since you see this is a by 2, and this is a, which is double of this. And again, in terms of tan, you can write it in this way. The cos a also follows the same logic. Okay, so again, tan a, you can also write it in the same way. So for example, let's say I want to write sine 4a. You can write this as 2 sine 2a cos 2a. Using the same logic, which is this angle is double of this. Sorry, this angle is there and this is double of this. Similarly, cos 4a. Let's say in terms of cos, you want to write down 2 cos square 2a minus 1. In terms of sine, you want to write it down 1 minus 2 sine square 2a. Okay. Then you have sine a by 2. You can write this as 2 sine a by 4 cos a by 4. Yes or no? You see this one? This is double of this angle. Similarly, tan a by 2, let me write in terms of tan. So you will get 2 tan a by 4 divided by 1 minus tan square a by 4. So I hope this is clear for everyone. Okay. So now what we will do is, so using the submultiple angle formulas, multiple angle formulas, you can easily figure out the values like sine 18, cos 36, guys. You can easily figure out these values. Okay, so for example, let's say you have sine 18 degrees is equal to root 5 minus 1 by 4, okay, is equal to cos 72 degrees. So how do you find the sine 18 here? So again, remember them, but what is the proof of this? I'll do one question for you. So let's say you want sine 18 degrees. Okay, so how do you do this? You can take theta to be 18. So what is, let's say, phi theta? What is going to be phi theta here? Phi theta is going to be 90 degrees. You can write this as 3 theta is equal to 90 minus 2 theta here. If you apply sine on both the sides, I'll get sine 3 theta. Sine 90 minus 2 theta is cos 2 theta. Right. So what is this going to be now? So this you can write it as sine 3 theta is 3 sine theta minus of 4 sine cube theta. Okay, and now you can write cos 2 theta in terms of cos, or else let me do one thing, guys. Let me make it more simple for you. Okay, so let us take 2 theta on one side and 3 theta on the other side. I think that will become more simple for us. If you see, if I apply, let's say, sine on both the sides, okay, let me apply sine on both the sides. I'll get sine 2 theta here. The sine of 90 minus 3 theta, that will become cos 3 theta. Now what is sine 2 theta? The formula 2 sine theta cos theta. What is cos 3 theta? 4 cos cube theta minus 3 cos theta. So you can clearly observe that here the cos is getting cancelled. Now what is remaining? 2 sine theta is equal to 4 cos square theta minus 3. Now this can be simplified. You can write this as 4 into 1 minus sine square theta minus 3. So 2 sine theta is going to be how much? 4 minus 4 sine square theta minus 3. So this is what we are going to get here. You're going to get 4 sine square theta, okay, and this is going to be minus 1 plus 2 sine theta is equal to 0. Now this is a quadratic formula in terms of sine. So from here you can write sine theta as minus b plus or minus under root of b square minus of 4ac. I think something is wrong here. Just a minute, guys. 4 sine square theta minus 1, perfect. So 4ac, and that's going to be basically 16 divided by 2a, and that's going to be 2 into 4. So you can clearly see this can be further simplified to sine theta. So this is minus 2 plus or minus under root of 20, and that can be written as 2 root 5. So basically I'm getting this one, minus 1 plus or minus root 5 divided by 4. Okay, so anyway I can't take negative. Theta is 18, first quadrant, so sign should be positive. So in this plus or minus I'll be taking only plus, and this is the value you are going to get. Okay, so this is the proof of the first one. Similarly you can do the proof of the second one, guys. So the thing is here you need to understand that, okay, it's fine if you want to remember the proof, it's fine, you can do this. But in the examination, you know that there is not that much of time with you, okay, where you can spend, at least 3-4 minutes, or let's say 4-5 minutes in getting those values. So remember that, if you directly know what is the value of sine 18, which is what is cos 36, it would become easy for you. You would definitely save a lot of time there. So sine 18 is root 5 minus 1 by 4, which is also cos 72. Cos 36 is root 5 plus 1 by 4. Okay. Now let's say you want to figure out what is sine 22 and half and tan 22 and half. Now how do you do this, guys? Let me ask you, how do you find out sine 22 and half degrees? Okay. Now what I'll be doing is, I know that cos 45 degrees can be written as 1 minus 2 sine square 22 and half degrees. Yes or no? Cos 2 theta 1 minus 2 sine square theta formula. So from here, guys, what is sine 22 and half degrees going to be? It is 1 minus cos 45 degrees by 2 whole under square root. So the value is 1 minus 1 by root 2 divided by 2 whole square root. So I'll be getting root 2 minus 1 by 2 root 2 whole square root. This is what I'm going to get. I hope it's clear for you. Similarly, if you want to find out let's say tan 22.5 degrees, guys. Now how do you do this, guys? Tan 22.5, same logic. What you can do is tan 45 degrees is 2 tan theta. Tan 2 theta is 2 tan theta. That is 2 tan 22.5 degrees divided by 1 minus tan square 22.5 degrees. Okay, and tan 45 is going to be equal to 1. So substitute. You can just take this to right hand side, solve the equation. If you solve the equation, this is what you're going to get. Tan 22.5 degrees value, you are going to get it as root 2 minus 1. So I hope this is clear for everyone out there, like how do you figure out sine 22.5 and tan 22.5. Now in addition to this, there is another important result as well. For example, let's say you want to find out sine 20 into sine 40 into sine 60 into sine 80. Okay, now how do you do this one? So here you make use of this type of results. For example, let's say in this result, if I take A is going to be 20 degrees, no, you see what I'm going to get. I'm going to get sine 20, okay, into, this is sine 60 plus 20, that is sine 80 into, and this is sine 60 minus 20, sine 40, and that is equal to 1 by 4 sine 3 into 20, and that is 60. Sine 60 is root 3 by 2. So I'll be getting root 3 divided by 8. So this value is root 3 by 8. Now here, this into this into this is therefore root 3 by 8 into sine 60 is root 3 by 2, and the answer which you have to get is 3 by 16. So see how simple it is. So you can basically make use of such results, guys. Remember this result, sine and cos. In such type of questions, directly if you put that respective value, you would end up getting the answer directly. Okay. So now what we will do is, so this is it. This is what is there in the syllabus of trigonometry for your KEAM 2023. Now what we will do is, let's do few questions, previous year questions. So this is 2020 questions, guys. I've taken directly from the PDF, which is available on the official site. Okay, you can see how many questions were asked in KEAM 2022. 1, 2, 3, 4, 5. You have 6th one and the 7th one. Okay, but trust me, these are very simple questions. For example, let's do the first question. Okay, you'll get a feel like whether these questions are easy or not. So one thing is that if you see the questions, let's go with the question number 40. Now question number 40, what is given for you, guys? So question number 40, what is given for you? Sine square theta plus 2 cos square theta is 7 by 4. You need to calculate the value of theta. Now cos square theta, you can definitely write it as 1 minus sine square theta. Yes or no? Or else you can also do it in this way to make it more simple. Let's do it this way, man. Sine square theta, you can write it as 1 minus cos square theta, and this is plus 2 cos square theta, and that is 7 by 4. So I'm getting cos square theta to be 7 by 4 minus 1, which is 3 by 4. So cos theta is basically root 3 by 2. So what is theta? Theta should be in the first quadrant. So theta is simply going to become pi by 6, 30 degrees. Option B is going to be the right answer. So any doubt here? Pretty simple. Okay. So question number 40 is done. Similarly, what about question number 41? If you observe here, guys, question number 41 is damn simple. See, the thing is, let me do it in the next slide. Question number 41. Okay. So what is given is sine square 1 degree. Sine square 1 degree plus sine square 2 degrees plus sine square 3 degrees plus so on. Just let me write down sine 45 in between. Okay, sine square 45 degrees, and let me go to the final one, which is sine square 89 degrees. And what else we have? 91, right? No, not 91. I think, yeah, 89 and 88. Okay. Now observe this one, guys. So let me write down the last three at least. Okay. So sine square, I think 87, sine square 88, and sine square 89. Now this is pretty simple. Sine square 89 can be written as cos square 1, because you do know that sine 89 is simply nothing but sine 90 minus 1. and this is nothing but sine 90 minus theta cos theta. So this can be written as cos 1 degree. So what is going to happen is sine square 1 plus cos square 1. Sine square theta plus cos square theta is simply going to become 1. Similarly, sine square 88 is cos square 2 according to this logic, and sine square 2 plus cos square 2, that is also going to become 1, right? So in this way, how many pairs are you going to get here, guys? So till 1 to 44, you're going to get 44 pairs, agreed? So it's going to be 44 plus sine square 45 is going to be 1 by 2. Okay, so how much is this going to become? 44 into 2 is 88. 88 plus 1, that's 89 by 2, and definitely we have the option C, and that's the right answer. Okay, so I hope this is clear for everyone. So pretty simple. Next, sine raised to 4 pi by 8 plus sine raised to 4 3 pi by 8. So how do we do this question? Now again, what is given? Sine raised to 4 pi by 8 plus sine raised to 4. Now instead of writing 3 pi by 8, can I write as pi by 2 minus 3 pi by 8, everyone? 3 pi by 2, it's not 3 pi by 2. Pi by 2 minus of pi by 8. Pi by 2 minus of pi by 8. Definitely 3 pi by 8 instead of writing. So what is going to happen is sine raised to 4 pi by 8, and this is sine of 90 minus theta. So this is cos raised to 4 pi by 8. Now if you observe this one, this is of the format a raised to 4 plus b raised to 4. And what is a raised to 4 plus b raised to 4? A square plus b square. So I can write it as sine square pi by 8 plus cos square pi by 8 whole square, a square plus b square whole square minus 2 a square b square. So minus 2 sine square pi by 8 into cos square pi by 8. This is pretty simple. All I am telling you here is a raised to 4 plus b raised to 4 can be written as a square plus b square whole square minus of 2 a square b square. Okay, and that is what we got here. So observe here, sine square theta plus cos square theta, that is 1, minus of 2 into, what we'll be doing is, let me multiply and divide by 4. So here it will be 4 sine square this and cos square this, which can also be written as 2 sine pi by 8 into cos pi by 8 whole square. Okay, now observe this one, guys. 1 minus, this is 1 by 2 into 2 sin theta cos theta sin 2 theta. So this is sin 2 theta, that is sin pi by 4 whole square. So what am I going to get here? 1 minus 1 by 2 into sin square pi by 4, that's 1 by 2. So I'll be getting 1 minus 1 by 4, and that is going to be 3 by 4. And guys, do we have an option here? Yes, option B is going to be the right answer. So any doubt on this question? I hope this is clear for all the students out there. Okay, so this is how you have to do it. Pretty simple, pretty basic stuff. Okay, so now what we will be doing is, let me go to the next question. The value of sine 45 plus theta minus cos 45 minus theta. How simple is this question, guys? What are we going to do here? Observe this one, guys. Observe this one. So here what you can do is, see here, simple question this is. So let me just do it directly here. So sine 45 plus theta. So this what did we get the answer as? I think this was 30, this was 89 by 2, this was 3 by 4, right? Right. So here sine pi by 4 plus theta, so this is going to be basically sine 45, okay? Or else let me do one thing, guys. Let me just do this question somewhere in a new page so that it's going to be clear for you. So here again it's the formula thing. Sine, you have 45 plus theta, right? Yep, 45 plus theta minus of cos 45 degrees minus theta. This is sine of a plus b. So that's sine a, sine 45. So directly we can write this as 1 by root 2 into cos theta plus 1 by root 2 into sine theta minus of, what is cos of a minus b? Cos a cos b, that is 1 by root 2 cos theta, okay, and plus 1 by root 2 sine theta. And if you observe this, guys, the terms are getting cancelled. This term, this term, this term, this term is getting cancelled, and the result is simply 0. And do we have an option here? Yes, the option E is going to be the right answer here. Okay, chalo. Next one, cos 2x is equal to cos x. What are the values of x which will satisfy this equation? So again, cos 2x is going to be equal to cos x. Now what is cos 2x? 2 cos square x minus 1, and that is equal to cos x. So let me take this side. So 2 cos square x minus cos x minus 1 is equal to 0. So let me solve this one for you. So this is, if you factorize this, 2 cos square x minus 2 cos x plus cos x minus 1 is equal to 0. If you can take 2 cos x as a common, okay, so what will be left out? Cos x minus 1 will be left out, and then here if you take 1 as a common, cos x minus 1 will be left out. So basically guys, cos x values I'm getting it as minus 1 by 2, and another value of cos x is going to be 1. We need the angle in the interval 0 to pi. So what does that mean? 0 to pi, x is going to be here pi minus pi by 3, that is 2 pi by 3. And for this, cos x is equal to 1, x we can take it as pi, not pi actually, we can take it as 0. Because between 0 to pi, cos x is going to be 1 at 0. So 0 and 2 pi by 3 are the values guys. So 0 and 2 pi by 3, yes, option A is going to be the right answer. So any doubt in this question? I hope it's clear. So these are basically pretty basic questions. I don't think you'll have any difficulty in solving these questions guys. Pretty basic. If you know the concept, you know the formula, you can directly apply here. Okay, similarly you have the next question. You see this question guys, tan x plus tan y is 5 by 6. Cot x plus cot y is 5. And what is tan of x plus y? Now observe here, tan of x plus y formula is tan x plus tan y, tan x plus tan y by 1 minus of tan x into tan y. Already tan x plus tan y value is given for you. You need to find tan x into tan y. For that, this is the condition given. Cot x plus cot y, that can be written as 1 by tan x plus 1 by tan y, and that is 5. If you take the LCM here, I'll get tan x plus tan y in the numerator. In the denominator, it's going to be tan x into tan y, and that is going to be 5. So already we know tan x plus tan y value, which is 5 by 6. So here, what is tan x into tan y then? From this equation, tan x into tan y will become 5 by 6 divided by, if you take this 5 to this side, it will be 5, and that is going to become 1 by 6. Now substitute this value in this equation guys. So what am I going to get here? So tan x plus tan y, 5 by 6 by 1 minus tan x into tan y, that is 1 by 6. So it's going to be 5 divided by 5, and that is going to become 1, and option E is going to be the right answer. So I hope this is clear for everyone. And similarly this question, this is the pretty simple question guys, pretty simple question. You see here, this is sine 1 degrees, sine 91 degrees. Okay, now sine 91, you can write it as sine of 90 degrees plus 1 degree plus sine 1 degree here. And similarly sine 91 again here, so sine 90 degrees plus 1 degree minus sine 1 degree. Okay, now sine 90 plus theta is cos theta. So I'll be getting cos 1 degree plus sine 1 degree divided by, this is again cos 1 degree minus sine 1 degree. I can take cos as a common. If I take cos as a common, if you see in the numerator, I'll get 1 plus sine by cos, which is going to become tan. So 1 plus tan 1 degree, and this is going to become 1 minus of tan 1 degree. Now what is 1 here? We know that 1 is going to become tan 45. 1, I think let me write it down with this, ink, so that it will be visible. So 1 is tan 45 guys, and this is tan 1 degrees. And similarly, what is this one? 1 minus, instead of writing tan 45, instead of writing tan 1, I can write this as tan 45 into tan 1, because anyway tan 45 is 1. So So you write tan 1 or tan 45 into 1, it's the same thing. Now you observe this, tan A plus tan B by 1 minus tan A into tan B. What is that going to become? Tan of A plus B. So tan of 46 degrees is going to be the answer. And if you see the options, guys, option A is going to be the right answer. So I hope this is also clear for you. So this is how you have to do this question. So I don't think you'll have any difficulty in solving this type of questions, right? So definitely, guys, this was the 2020 KEAM paper. Okay. So similarly, I want you guys to do the previous year questions from this particular chapter so that you'll get an idea what type of questions are being asked, how comfortable you are. So definitely whatever, we have discussed in the today's session, the formulas, the questions, all the trigonometric basics, this will be very helpful for you, and this will be enough for you to tackle any type of question from trigonometry in your KEAM examination. Okay, so with that, let's wind up the session today. I think that's it from today's session. Let's meet in another session with another interesting chapter, and till then, take care everyone. If you have any doubts, just let me know in the comment section below. I'll definitely try to reach out to you I'll definitely try to reply to you guys as soon as possible. Okay, so with that, take care everyone. Bye guys. And if you find this session very useful, very effective, do subscribe to this channel and also like the video. Okay, so bye everyone. Take care.